Good morning and welcome to another question in Projectiles. And the question we're doing today is MEI question. And this is a complete question of 18 marks. So that should cover quite a lot of what we need to do. Okay, guys, what does it say? Figure 7 illustrates the trajectory of a tennis ball which has been served with a player. I'll give you a couple of seconds to read it. Okay, and so we pause the video and read it from here. And all this information is done on this diagram. Okay, so I've recorded all this information in my paper and we'll be moving on to the question now. Right. You must have read by now. Okay? So it says Hamish serves the ball with the components of velocity 10 meters per second horizontally. For Hamish, it is 10 meters per second this way. And it is 5.5 meters per second, 5.5 meters per second vertically. Okay, find the speed of Hamish serve in the ball and serve and the value of alpha. Okay, so guys, what we need to do, we need to work out Hamish's speed. Speed will be the, as you know, this is the magnitude of the velocity. So we find the resultant velocity and then find the speed there. Okay, so speed will be 10 squared plus 5.5 squared and square root. Okay, so we work out on a calculator. Okay, so 10 squared plus 5.5 squared in the calculator gives me 521.2. So that is 11.41. So in two decimal places, 11.41. Let's say with two decimal places, we're working out. Okay, right. And the angle theta would be, once again, guys, the same thing. We just work out the angle theta. So it will be tan inverse of 5.5 divided by 10. I can work that out in the calculator as well. Right, so which comes out as 28.8 to one decimal place. 28.8 to one decimal place. And I'll probably say we'll do this as 11.4 as well, because like I said to you before, in mechanics, we use generally G equals 9.8 to one decimal place. So we just try to have everything at least up to one decimal place or three significant figures or both. Okay, right, guys. So the next question now is sharing screen again. It says, part 2, show that Hamish's serve passes over the net. Okay, so Hamish's serve passes over the net. What does that mean? We're going to be making sure that his serve, when it serves from here, when it's traveled 12.5 meters horizontally, its height is above more than 0.995. Okay, let's say we're working on Hamish again, and Hamish, like I said, every projectile question can be done in two parts. Okay, so horizontally it is speed equals distance over time, and vertically it will be silhouette. Okay, so horizontal speed I know is 10. So speed equals 10, and the distance I know is 12.5. So can I work out time for this? Okay, then I'll find out what at the same time, how much is the height of the ball. Okay, guys, you can pause this and do it yourself. Then we can take it from there. Right, so time comes out as 1.25 seconds. So I will transfer this time to we need to work out how much is the height of this ball when it has traveled 12.5 meters distance horizontally, or when it has traveled for 1.25 seconds. So like I said, when the modeling of freely falling bodies, everything goes up, I take it as positive. So acceleration will always be negative. U is positive because it's going upwards. Okay, and we're going to work out the height, the S. So guys, you can pause it here and see which silhouette you want to be using and working this out for me, please. All right, the calculator gives me minus 0.78125. It is minus 0.78125 meters. But guys, really important part, this is where the mistake happens. Okay, in my experience, this is where people go wrong. This is negative 0.78125 below from its original starting position. So guys, how much is the height from ground then? Which will be 2.22, take away 0.78125. So we put that in the calculator and check if that is bigger than 0.995. And guys, this gives me 1.43875. So 1.43875, which is definitely above 0.995 from the ground. So that means Hamish's serve will clear the net. Right, guys, the next part is find the time at which Hamish's serve hits the ground. So this also is the vertical motion part of the question. Okay, so what do we do in this case, people? We're going to find the time when Hamish's serve is hit the ground. So to come to the ground, it has to travel 2.22 meters vertically downwards. So we do suet again. Let's do suet there. Okay, so S would be minus 2.22 because it will come down. Okay, U, we know vertical speed is 5.5 going upwards. Okay, A is minus 9.8 and time is what we have to find. All right, guys, I will give you a chance to pause this and work it out yourself, please. All right, guys, so we get to this quadratic equation, which I put in the calculator, and that gives me the answer of X as 1.437. So T is equal to 1.4376 and T equals to minus 0.315, which obviously we'll have to ignore. So this is the time at which Hamish's surface hits the ground. And then it says in the second part of the question that does it fall in the surface area? So guys, we're going to work out now how much horizontal distance does it travel in this time. And if that distance is between 12.5 and 19, because that's 6.5, that means it will fall correctly in the surface area. Can you do that for me, please, now? Thank you. Right, so we worked it out, guys. So resolving horizontally, in horizontal direction, distance is equal speed times. So this speed is 10. So that's 10. So 10 times 14.3, that gives you 14.376, which is in between 12.5 and 19 there. So yes, service will fall into the serve code properly. Thank you. Let's look at the next question then. Right, so once we've done these first three parts of 9 marks, guys, this is question changes. Now we talk about Oscar now. Oscar hits the ball horizontally, so alpha equals 0. This is really important, guys. The diagram, I'll show you that in my picture a little later. Horizontal ball speed means what? There's no vertical speed going up at all, okay? Thrown the ball horizontally, just straight in that direction, okay? Still, ball will travel in projectile motion, will come down. So speed is u. Find the range of possible values of u for which the ball lands in the service code. This is a good one. Pay attention very carefully. Right, guys, so I've drawn the diagram. This is the diagram when horizontal speed is 0, horizontal speed is u and vertical speed is 0. Okay, this is the first scenario. The minimum speed should be that ball should cross the net. Okay, and the maximum speed should be that ball should not go over the service, outside the service code. This is the maximum speed. Guys, if you find these two minimum and maximum speeds, that will be the range of speeds we can have. Okay, so let's call this scenario 1. Let's call this scenario 2. Okay, so in your scenario 1, what's going to happen? You're going to find out the speed so that it passes over the net. Okay, so that means, let's say you knew vertical 1. So how much is the distance it has to travel to be able to pass over the net, guys? How much is the distance there? This is 2.22 take away 0.995, which we would have worked out before. Take away 0.995, and the answer is 2.22 take away 0.995, and it is 1.225. So guys, if S is negative 1.225, okay, A equals minus 9.8, and U equals 0, obviously, because there's no vertical speed at all. So can we work out the time for this? Okay, so time would be, if you use your S equals UT plus half AT squared, just work out time for me, please. And let's see how much time does it take to travel 1.225 meters downwards, okay? Right, so this comes out as T equals half Okay, so now we work out how much is the speed when time equals half second, how much is the horizontal speed. Remember, it had only horizontal speed, didn't have any vertical speed. So guys, speed equals distance divided by the time, and distance up to the net is 12.5 meters horizontally. Okay, so speed equals 12.5 divided by 0.5, which is half, and that is double of that, so s equals 25 meters per second. So guys, this is the minimum speed the Oscar should serve his ball so that the ball crosses the net. Okay, sorry for the cramped space. We do the second scenario here as well. So guys, what we need to do now, we need to work out this speed, because if he hits it too hard, it's going to, there's a chance that it will land at above or more than 19 meters on the ground. So let's find out the time for it to reach the ground. Time to reach the ground. That means S is equal to minus 2.22. U is U, obviously, okay, and A is minus 9.8, and U0, sorry, this is vertical again, and we're going to work out the time. Okay, so guys, use to that again, work out the time for it to reach the ground. Okay, then match answer with mine, pause it. So which comes out as 0.673 and so on. Now guys, we need to see that this should be the time when the horizontal distance should be less than 19 meters. Okay, so the maximum speed, horizontal speed, should be less than or equal to distance over time. So 19 divided by 0.673 and see how much you get. That should be the maximum speed of this. And this comes out as 28.22. So guys, this is the speed. It should be minimum this speed so it can cross the net. It should be maximum this speed so it doesn't fall beyond 19 meters. So speed should be, the range of U should be greater than or equal to 25 meters per second and less than 28.22 meters. Okay, so that will be that 6 marker here. Okay, so the next part is about Tara now, and Tara is the top player. She serves the ball at 2 degrees below the horizontal. So guys, horizontal 2 degrees below the horizontal, and the ball clears the net. So that means ball cleared the 0.995 meters distance when the horizontal is 12.5 meters, and bounces after 0.5657 seconds. I mean, time's taken to come down. This 2.22 meters distance is 0.57 seconds. And we're going to work out the initial speed. So as you work out the horizontal and the vertical speed, then vertical velocities, then you do what you're going to be working out the magnitude of that to find the speed. Okay, so pause the video and see if you can work that out yourself, then match the answer with mine. So guys, let's see, let's make the diagram for the Tara speed. It's coming downwards. This is 2 degrees. That's U is what we have to find. And this component will be, this will be U cos, that'll be U sine theta. Okay, so vertical velocity U sine theta. Let's do S U V A T. So U equals coming downwards minus U sine theta. This is minus 2.22. Okay, because we want further to the ground, and A equals minus 9.8. And what are we given with is the time. I understand it. They given, we know the time there. Yeah, time is 0.57 seconds. So guys, we use the equation S equals ut plus half at square and try and work out the value of this. Then sine theta means sine 2 degrees. Come on guys, work that out. Then we check the answer with mine. Right, so we S equals ut plus half at square, rearrange, got to this stage, and that gives me minus 31.568 or so on. That means U acting downward should be 31.6 meters per second roughly. Right guys, so this is the question, and then we finish it later.